Before we start, so instead of doing a representative rectangle, we're going to be doing a representative washer today. So don't judge my art skills. So it'll look something like this, and then you'll be revolving your washer around an axis, and kind of like that. And you will get, what color do I use for the big one? I usually use blue to represent big R of X, and then you're going to have a smaller radius. Ooh, big turnover for little R of X. So you're going to have a radius of the big circle, a radius of the little circle. We're going to be integrating, we're going to be using pi r squared again, except we'll be subtracting the two radii so that we're just left with the solid part. So essentially you're having you're filling a full cylinder with the big R of X, you're filling the smaller cylinder with the small green R of X, and then you're subtracting the two to get the leftover washer. And I think we moved from just rotating about an axis to rotating on some horizontal and vertical lines as well. All right, so this is all the shebang, the fancy stuff they're talking about. So if you have a flat region, a plane region, and then you draw your representative rectangle and you start spinning it around an axis, revolving it around an axis, you get your 3D figure, and it's going to create a washer. So just like I said, we're going to imagine that we have a big cylinder that we're filling, a small cylinder that we're filling. We subtract the two to get the washer. Your region, it's still the same formula, except we're subtracting the two radii. So last time we had pi times r of x squared, because it was just a solid circle and we called it a disk. But now we're going to have big R of x squared minus little r of x squared. And they have the pi in front of the integration, just like we did before. You have to be super careful. It's super important that you draw that representative washer so that you guys understand the top function minus the axis or minus the line that you're going to, or then the second function to the axis. But it's always top minus bottom again. And then if we do our washers the other direction, it's still right minus left. A's and B's when it's the X's, C's and D's when it's the Y's. Let's get rocking and rolling. We're going to do the whole saving time with it. Hey, this is what you should get your answer to be. All right, rotate the region between y equals the square root of x, y equals 1. So we're going to do that in blue, y equals 1 in green. And then it's also bounded between x equals 4, which is a vertical line. And we're rotating it around the x-axis, and our goal is to find the volume. So we're going to go ahead and we're going to graph y equals the square root of x, which we all should know how to graph. 0, 0, 1, 1, 4, 2. You've got the line y equals 1, which is horizontal at 1. And then the vertical line x equals 4. So that little rounded triangle looking thing, if you will, that's the area that we're revolving around the x-axis. So we're spinning around the x-axis. And that little sliver is what we are rotating. So when we spin it, oops, my off. No. 1, 2, 3, 4. You get this hole in the middle of your 3D shape. And so instead of having a solid disk to find the volume, we're going to have a washer to find the volume. So our washer, you're going to have the top touch the blue line, and then the inner circle touches the green. So the top of your radius touches, or the top of your circle, the big R is going to touch the blue. And then inner radius, the top of it touches the green. And I always like to draw a bigger one out to the side. So this line would represent my x-axis, which has, what is its equation? The x-axis is y equals 0. And then the inner, the little r of x, touches the equation y equals 1. And the big R of x touches y equals the square root of x. So this one is a fairly easy example because when you do top minus bottom, so if you're looking to find big R of x, and you do top minus bottom of the radius, the top of it is touching the square root of x. The bottom of the radius is touching the x-axis, which is 0. And the square root of x minus 0 is just square root of x. So big R of x is the square root of x. It only works out nicely when you're revolving it around one of the axes. If you're revolving it around a different line, you would have, like, if we were revolving around y equals 1, we would have the square root of x minus 1 as our radius. And then little r of x, the top of it touches 1 minus 0, which is just 1. It's pretty easy to see the points of intersection on this one. Remember, if you can't tell what it is from the graph, you can always set them equal algebraically. So if you set the square root of x equal to 1, you would get 1. And if you set the square root of, the square root of x is also intersecting just the line of 4. So it's intersecting at 1 and it's intersecting at 4. Pretty easy on this one. So we're ready for our volume. So we're going to have volume equals, I'm going to write the formula down on this one, pi from A to B of big R of x quantity squared minus little r of x quantity squared dx. So you can't just square, you can't do r of x, big R of x minus little r of x and square it. You have to square the big R of x, you have to square the little r of x. So we'll substitute in and we'll have pi equals A to B in this case would be where they intersect at 1 and 4. Big R of x was the square root of x. Close it, square it, minus little r of x, which is just 1. Close it, square it, dx. All right, so what happens here with the square root of x squared? Oops, I didn't. Why didn't you guys say, Miss B, put an extra equal sign? Miss B, put an extra equal sign. Oh, thanks. Pi from 1 to 4, square root of x squared just leaves us with x. 1 squared is 1, so it's x minus 1 quantity squared. Gosh, Miss B, don't put the quantity squared. Don't put the quantity squared. X minus 1 dx. That's just something I told you not to do. All right, now you're ready to integrate. It's just power rules. X becomes x squared over 2. Negative 1 becomes minus x. And we're bounding from 1 to 4. And then it's exactly what we did last time. So, and to answer that, we got a bunch. 9 halves pi Popular answer.
Yeah, me too.
It's because of we use the same functions kind of over and over with the same bounds. Keep it small. So remember, you're doing volume, so it's cubic units. That was a fairly easy example again because we were just taking it to the x-axis, which had the y equals 0 equation, and we could tell our bounds pretty easily. The next one, find the volume of the solid form by revolving the region bounded by the graphs of y equals square root of x and y equals x squared. So y equals the square root of x, I'm going to do in blue. Y equals x squared in green. It says we're rotating about the x-axis. Between, and this one's nice because they give us the bounds of 0 and 1. And square root of x, pretty easy for us to graph. Remember which way to curve it. So square root goes this way. Y equals x squared has the same first 2 points, except it's curving like a parabola. So we get a shape that kind of looks like a petal. And again, the points of intersection were easy on this one because we know the square root of x, we know y equals x squared. Remember to find your points of intersection. If it's not obvious, set the two functions equal. So if you had the square root of x equals x squared, what would you do here? How would you get rid of the square? Or the root? I said the answer. Dang it. So to get rid of the root, you would square it. So you would get x equals x to the fourth, then you'd have 0 equals x to the fourth minus x, and then you'd factor. 0 equals x times x cubed minus 1, x equals 0, x cubed minus 1 equals 0, x cubed equals 1, x equals 1. So if you can't see it from the graph, don't forget that you set the equations equal to solve for it. All right, so now we need to revolve it around the x-axis. So draw the petal that would land down below. So you have your square root coming this way, your x squared coming that way. And we are revolving that. It's the gray. Gray is not up there yet. Come on, colors. So that's what we're revolving around the x-axis. So kind of, I don't know, looks like, I don't know what that would look like. A horn?
Like one of those seeds that like that's I don't know what they call it. It like falls with the house.
Oh, yeah. I thought you said a seat that spins around. And I was like a sitting spin? I'm not seeing it. All right. Washer, draw a washer. That's what's next. So the big R of x goes up to the blue line. Little r of x goes to the green line. A plunger? A blender. I can't hear. Yeah. All right, we got our little axis coming through there. So again, we're rotating about the x-axis, so we get y equals 0. Little r of x is the equation. What was our green guy? X squared. And big R of x is y equals the square root of x. So once again, when you go to find big R of x and little r of x, these two aren't horrible because you're taking it to y equals 0. The big R of x, remember that you always want to do top minus bottom. So top is the square root of x minus the bottom of big R of x, which would be 0. Just leaves us with the square root of x again. Little r of x is x squared to 0, top minus bottom, which just leaves us with our x squared. Then once you get both of your radii, we're ready to set up the volume, our integration. We've got pi. Our bounds are what to what? 0 to 1. And remember, it's big R of x quantity squared first. So big R of x is our square root of x minus little r of x squared. Was x squared squared. I wish this thing would just disappear. Do you guys know how to just make that go away without hitting stop sharing? Oh, neither. Okay. All right, pi from 0 to 1, square root of x and the square cancel, so we're left with x minus x to the fourth, power of a power. Remember that you multiply. And so this one is also pretty easy to integrate. Just use our power rule. X will become x squared over 2. X to the fourth becomes x to the fifth over 5, evaluated from 0 to 1. And then this one is 3/10 pi, or 3 pi over 10. Remember that you do f of b minus f of a. All right, so we've done 2 of them around the x-axis. The next one, we're going to revolve around the y-axis. So our discs are going to be horizontal. Same thing, I'm going to do the first function in blue, second function in green. And this time we're going about the y-axis. This one is fairly easy to figure out what your points of intersection are when you graph it. Obviously, I gave you a pretty small graph, so you know it doesn't even go to 4. 0 and 1 again, we get our y equals x squared going like this. And then y equals x is what function? The identity, which has the slope 1, goes through 0, 0. So instead of a pedal, you've got that flat side there. So if you couldn't see, or you wanted to find your points of intersection before the graph, you just set them equal. And we wouldn't want to do it that way. Well, I mean, you would find your x bounds that way. We can go ahead and do that. 0, take out an x minus 1, x equals 0, x equals 1. So those would be the points of intersection for the x bounds, but we don't want points of intersection for x bounds. We want points of intersection for y bounds. So you would have square root of y equals y. It comes out to be the same thing. Square it, we get y equals y squared minus y equals 0, same shebang. Okay, you guys with me? Am I going too fast? I feel like this is stuff that you guys should be able to do. No, yes. Gotcha, Miss B.
Yes.
Okay. Alrighty, now we're going to go around the y-axis. Make sure you actually go around the y-axis. And I say that for myself, so I don't forget. Purple. So when you revolve it, it looks like a piranha plant, like those things on Mario. Well, they're not called Venus flytraps on Mario, but yes, it does look like a Venus flytrap. All right, so we're revolving that. Now our washers are going to go sideways. So this time, your big R of x is all the way to the right end, and your little R of x is on the green. This is why I always like to draw it bigger. And it's going to be r of y instead of r of x and little r of y. So instead of going top minus bottom, make sure that when you find r of y, you go right minus left. And make sure that your equation is in terms of y. So instead of using x squared, we should use, the blue function would be x equals square root of y. The green function would be x equals y, and then x equals 0. I don't know why I wrote in blue on all those. Let me fix that. Get your color coding together this week. I lost my train of thought. What was that guy? X equals y. There we go. All right, so right minus left. Again, this is fairly simple because you have your square root of y, and it's going to the y-axis, which is x equals 0, so you get the square root of y. Same thing with your little r of y. It'll just be y minus 0, which is just y. So on this one, when you go to find your volume, I'm going to write the equation down the first time on this one. It's v equals pi. They change the bounds from a to b to b, c, and d. Big R of y, quantity squared, minus little r of y, quantity squared, and then it's dy at the end instead of dx. Our y bounds are 0 to 1. Big R of y was square root of y. Little r of y was just y. Don't forget the dy at the end. Don't want to lose that half point. Square root and square cancel again. So we clean up to get 0 to 1 of y minus y squared dy. Integrate pi times y squared over 2 minus y cubed over 3 from 0 to 1. Anybody want to take a wild guess? It's not 9/2. It is pi over 6. You already worked it so fast. So pi over 6 cubic units. Do what? Did I not put units up? Ooh. Did I say cubic units and I wrote square?
Yeah, I think you did.
Hey. Minus half. Good. All right, so this next part, the next 1, 2, 3 examples are revolving so that you have a disc or a washer around something that is not an axis. So we're going to be doing, on the first one, it's y equals 2, but you can have anything other than one of your axes this time. So this makes the radii just a little bit more difficult, which then in turn kind of makes your integration a little harder. All right, so the idea here is still that you're going to have your slice, but your big R of x and your little r of x are not going to be minus 0 on this one. Same stuff, A to B, C to D. Remember to draw your reference rectangle, but it should also say disc or washer. So let's rock and roll. I'm just follow the same colors, blue, green, blue first, green second. So we're doing y equals negative x squared plus 4. So we've got a quadratic where it's 2 transformations. The negative is going to do what? Rock. So how's it going to open? Down, and then the plus 4 has shifted it up 4. So it's shifted up 4 and it's opening down. And then we have our horizontal line y equals 2. We're going to go about the line. y equals 2. So instead of rotating it around the axis, we're going about the line y equals 2. All right, so negative x squared plus 4. We know shifted up 4, 1, 2, 3, 4. It's opening down. So we're going to go left 1 and right 1 and down 1. Left 2 and right 2, down 4. Y equals 2. We've got our horizontal line, 1, 2. And that's also what we are rotating about. So on this one, are our points of intersection easy to pick out from the graph? No, the green and the blue didn't intersect. Turnover didn't intersect nicely. So we are going to have to calculate our points of intersection. So we want to set negative x squared plus 4 equal to 2. Negative x squared equals negative 2. We get x squared equals positive 2. When you square root it, how many answers are produced? 2. So we get positive and negative square root of 2 and just leave it as the square root. Don't change it to a decimal. So we know the points of intersection are positive 2 or positive root 2 and negative root 2. So we know those are also going to be our bounds that we're integrating between. When you go to rotate this one, if we were rotating it around the x-axis, so process this here. If we were spinning it around the x-axis, your whatever shape that is, dome, thank you, gumdrop, would be down here, and you would have a gap between the two domes, if you will. So your rectangles would create a washer because you'd have the big cylinder and the little cylinder, and you'd have that gap in between. So don't do this, but you would have that gap in between when you drew your washer. But because you're rotating it about the line y equals 2, when you go to rotate it, you don't have a gap anymore. So it's not a washer. It's back to whatever day I had you guys, Thursday. So it's just a disc. So you're not going to have a big radius minus a little radius on this one. Does that make sense? So if it had said rotate about the x-axis, we would have big radius minus little radius. This one has no gap in between what it's rotating around. So it's just a disc. Did we just do a rectangle on that one? Did we? Yeah. On Thursday?
Yeah.
So we're gonna have volume equals, I'm gonna write the formula down since we haven't used this one today, pi times a to b of big R of x quantity squared dx. So you just have one radius that you're squaring. Did I draw a disc on the last one, or did I just draw rectangles when I did top, minus, bottom on Thursday? I can't even remember. Did I do this and say it touched? I can't remember. Negative x squared plus 4 here. And y, I didn't?
No.
Okay. Well, this rectangle represents your big R of x. So the top of the rectangle is touching negative x squared plus 4. The bottom of that rectangle is touching 2. So on all the ones you did on Thursday, it was always touching what? 0. So you just got to do that's why, because we just did the top of the function. But I remember saying, now it's all coming back to me. I remember saying top minus bottom, and it's top minus 0, which is always still the top, but it's not going to be that way until next week. And now it's next week. So when you go to do top minus bottom, oops, I'm going to get in the way of that. It's all coming back. It's all coming back to me now. When you do top minus bottom on this one, you have negative x squared plus 4 minus 2. So last time it was minus 0, so it just left us with top. On this one, you need to clean it up. So we get negative x squared plus 2 as the radius. So really that's the only difference with the disk today is instead of taking it to 0, you're taking it to another horizontal line. So when we substitute in our points of intersection, negative root 2 to root 2, big R of x is negative x squared plus 2. Don't forget to square it because it is a circle, the radius of a circle. Close it, and dx. All right, so for this one, if you were going to try like u and du with u substitution, what would you have let u equal? Negative x squared plus 2, right? And then what would your du have been? Negative 2x, which you could take care of the 2 and balance it out and whatnot, but what do you not have? You don't have an x, so we don't want to go that route. So how are we going to, what do we need to do before we can integrate? We need FOIL, we need to square the function. So if you can do it in your head, that's fine. If you need to write it out, write it out. Just don't mess up if you do it in your head. Negative x squared plus 2 times negative x squared plus 2. So we're going to have negative x squared times negative x squared, which is positive x to the 4th. A negative x squared times a positive 2 is a negative 2x squared. And then on the inside, you get another negative 2x squared. And then last, you get a positive 4. So we get x to the 4th minus 4x squared plus 4 as our trinomial that we still need to integrate. So pi from negative root 2 to root 2 of positive x to the 4th minus 4x squared plus 4 as a quantity dx. All right, so we just power rule it. X to the 5th, and I wrote a 4. Wait. There we go. X to the 5th over 5. Add 1 to the power, we get a 3. So negative 4/3 x cubed plus 4x. Evaluated from the root 2's. Negative root 2 to root 2. You wouldn't be able to guess this one. 6. Do what? It's kind of ugly. 64 pi root 2 all over 15. That was your guess? Man, you're good. No, it's still volume. Because we're revolving. All right. Negative x squared plus 4 again. Y equals 2 again. For this time, we are going about the line y equals 4. Green. Y equals 4. Oh my gosh. All right. When my eyes get this. Do what? I'm not sure why I made it that big. So we still have that same function that's being up 4 and rocks. 1, 2, 3, 4. 1, 2, 3, 4. All these lines play tricks on my eyes up here. Why does my sometimes my color chart shows up here, sometimes it doesn't show. I don't know if it does that. So they changed the problem ever so slightly on this one, and instead of rotating it around y equals 2, we are rotating it around y equals 4. So when you rotate it, it's kind of gonna look like an hourglass. And you flip it up, start spinning it around y equals 4. A mallet? No, I was trying to think of like what 3D shape kind of looks like a bow tie, but rounded. And there's some kitchen utensil that looks like that.
No.
I feel like there's a kitchen utensil that looks like, I could be wrong. Oh, maybe not. It's not a meat mallet. But... No, not a potato masher. Anywho, it doesn't really matter what kitchen utensil I'm thinking of. All right, so disc or washer. All right. If you, oh my goodness, goobers. All right, this is a washer. It's going to have holes because, oh, I don't want that color. So you're going to have the inner here and the outer here. Ooh. All right, on your washer that you go and draw to the side or below, I left you a bunch of room for this. When you go to find the volume, you have to use the original portion of the graph. Don't use that flipped up image. You have to use that those original colors that we have. So on all the other examples, we've done our colors coming up here. We're going to go down here because that's the original portion of the graph. So we want the blue. Just kidding, that's not blue there. That's green, isn't it? Green, which was y equals 2. And then the inner portion of the radius is touching the blue line, which was negative x squared plus 4. So if you go on color coding, big R of x has always been the blue, and little r of x has always been the green. But the way that this one turned out and the way it was rotated, big R of x this time is green, and little r of x is blue. So when you go to find big R of x, you have to make sure that you go from the picture and you do top minus bottom. Top is, here's top 4, minus the bottom, which is 2. So it gives us a radius of 2. What? Is that the first time we've had a radius of a number and not a function? I think, at least today. And then little r of x. So top minus bottom. Top is 4 minus bottom, negative x squared plus 4. No, not squared yet. What? Are Are you saying it's going to be x squared? Yes. All right. So 4 plus x squared minus 4, which just leaves you with x squared. All righty. Did we find our bounds yet? All right. So your bounds, they end up being the same, yes, because your first function was the negative x squared plus 4, and then your second function was the y equals 2. So it's the same thing as before. Plus and minus root 2. So v equals pi in front from negative root 2 to root 2. So big R of x, this time with my green guy, and he was 2. So big R of x squared, so make sure you have 2 quantity squared minus little r of x squared, which was just x squared, squared dx. Pi negative root 2 to root 2, and then the function that will actually integrate will be 4 minus x to the 4th. Pi 4x minus x to the 5th over 5, all those power rules, negative root 2 to root 2. Anybody want to guess? Or did anybody go ahead and work it out faster than I was talking? It's close to last time, but not 32 pi root 2 all over 5. 23 pi over 7.
Pretty close.
All right, last one. This is really our last one. Wow. Maybe I'll hand the quizzes back out. All right, rotate y equals the square root of x equals 4, around the line x equals 5, and find the volume. So y equals the square root of x will be in blue. X equals 4 is green. We're going to go around the line x equals 5. So 1, 2, 3, 4, 5. And then y equals square root of x, so 0, 1, 4. So we're spinning it around the line x equals 5. 1, 2, 3, 4. There we go. So this one's like a volcano. Does look like a slot for a screw, but it would have a, like if you look at it 3D, like from the top view, it would look like this. So it looks like a donut from the top. So like, that's why I was thinking volcano. Anywho, all right. So our washers need to be stacked out, and I gave it away. Dang it, that it was a washer.
Good job.
Sorry.
I think we were good.
All right, yes, you guys are smart. Mr. Huntley, how you doing?
I'm great. I need to steal for my thing. Oh, real fast.
Yes. All this is sarcasm. You keep them as long as you want.
Fair enough.
All right, let's draw our washer in. Oh no! Dang it!
2 times on the same profile.
Ah! All right, there we go. Pretty washer. Good thing there's an undo button, right? Some people.
Yeah. All of these.
Oh my! Thank you.
You're welcome.
Got it. Add this. There we go. Okay. Remember that when you draw your washer, make sure that you do your big R of X and your little R of X to the original side of the graph. So we want to draw it to the left side of that red line. The big R of X is back to the blue. Little R of X is back to the green. Who said that? Carlos? When we actually do the, like finding the radius, but we have to make sure that we start at the right and go to the left, yes. But whenever you draw it on the function itself, you want to have the original part of the graph, not the revolved part. That makes sense? Revolve my function of 4 and square root of x. Aha, square root of x. Y equals the square root of x. Remember, you don't want to use that. So x equals y squared because we're stacking them. They're running horizontally, but you're stacking them vertically. So big R of x. Carlos reminded us we want to go right minus left. So the right side of the radius touches what we were revolving around, x equals 5. So we'll have 5 minus y squared, which is just 5 minus y squared. It would be r of y. Thank you. Good. G-O-O-D-E-Y-E. Good eye. Good eye. Good eye. It's an old softball cheat. G-O-O-D-E-Y-E. Good eye. Good eye. Good eye. Way to watch. Way to watch. Way to watch the ball go by. R of y. You guys have baseball chants, right? Sure. No. We did too. All right, R of y. So the little one, little r of y. I wrote y and not an x. Right minus left. So you would have 5 minus, that's a weird 5, 4, just gives us 1. So then to the volume. Oh, have we found our bounds? They're pretty easy from the graph on this one. Yeah. Oh, did I hear 4 too? 2. 0 to 4 would be x bounds, but we're going this way, so we have to stack it vertically. So we need the y's. So 0 to 2. So pi from 0 to 2, and we want big R of y squared minus little r of y squared. dy. Big R of y squared was 5. Did I say y squared? 5 minus y squared. Little came out to just be 1. Bless you. So 5 minus y squared, quantity squared, we need to make sure that we FOIL that out. So you would have essentially 5 times 5, which is 25. 5 times negative y squared, negative 5y squared. 5 times negative y squared, another negative 5y squared. Negative y squared, which would be positive y to the 4th. And from the little r of y, 1 squared, which is just 1, and then you have a minus 1. So it FOILs to get 25 minus 10y squared, and then you collect your like terms with the 25 and the minus y to get 24. So volume equals pi, bounded from 0 to 2. Do you want to put the y's first?
Yeah.
All right, so we'll have y to the 4th. The negative 5y squared and the negative 5y squared makes negative 10y squared. And then the positive 25 and that negative 1 gave us 24. Power rule it. Y to the 5th over 5 minus 10 thirds y cubed plus 24y evaluated from 0 to 2. Ooh. Anybody want to give it a whirl? Nope.
416 words.
I have pi over 5 written down.
No.
416 pi over 5 cubic units. Woohoo! You have, I really condensed this down. 1, 2, 3, 4, 5, 6, 7 questions, because they kind of take, and then there's a challenge question, number 29. It would do what? You don't get extra credit, but if you are up for the challenge, it is not going to be on the homework quiz. What?